So I want to talk about, well, thanks for your patience. This is the first time I'm presenting on Hubs, so there are a couple of, strange technical issues that you have to deal with, especially when you're on an ancient iMac like I am. So I want to take a moment to talk about this project that I was working on when I was artist in residence at the Montmégantic Observatory. That was 2 summers ago. And I really loved my time there. And one of the many research areas at Montmégantic is the hunt for exoplanets. So I did a little research as I was thinking about what kind of project I could be doing, and I came across a really interesting quote. So yeah, that's the time at the Montmégantic. If you've ever been to the Montmégantic or the Montmégantic Park, if you it's a lovely place. If you haven't been, I highly recommend that you visit because it's absolutely beautiful. And during the summer months, unless there's COVID-19, you can actually visit on weekends. They have like a public astronomy nights where you can get to visit the observatory. Normally it's closed to the public, but during this time, it is actually open. So I was there from March till September 2018, and there was an exhibition also, and the resulting work has actually been shown a couple of times. So this is in my research about what what the kind of research that goes on at Montmégantic into exoplanets. I came across this really interesting quote that the definition of an exoplanet, it's very difficult to classify them, that there's no really good taxonomy. And the reason is that most of the exoplanets that we are finding are named after planets that we have here in our solar system, because these are the only planets that we know. So we know Jupiter's, and we know Earth-like planets, and like gas planets like Jupiter and Saturn. But a lot of the worlds that are being found and through the search for exoplanets, all that research, is planets that have no equivalent to Earth or solar system type planets. They are kind of like super Earth or ocean world ice giants. So sometimes you call them warm Saturns or hot Jupiters. And really, and I was looking at this, is this the best way to classify this new thing that we're finding in the universe? And I find it so anthropocentric that we always name things after ourselves. Maybe we should name exoplanets after themselves. And so I got this idea to create, to see if I could create a new taxonomy for exoplanets. And that's the origin of the idea Exoplanet Zoo. So I started in the 3D modeling software, and I thought I will do this. I just create a regular sphere in the 3D modeling software, and when you are in a software like, say, Rhino, you can save the Sdl file. So an Sdl file, for those of you who don't do a lot of 3D modeling, an Sdl file is like the equivalent like of a JPEG file if you're doing an image, or a text file if you're writing text. So Sdl is a very ubiquitous file format for any object that you're creating in the 3D program. And typically, if you want to 3D print something, you would save it in an Sdl file. And normally, when you open like a JPEG or an Sdl file, it's just gibberish. But if you save it in an ASCII format, you can actually get the code. So this is the actual code that describes every little vertex or triangle that makes up the sphere. And I thought, wouldn't it be interesting in all these numbers if I substituted exoplanet data for the numbers in this code? So I'm basically glitching the sphere to create new interesting shapes that are based on the actual data of exoplanets. So the kind of data that I entered was the mass of the planet, its orbit, inclination, and you can see this a little bit. Now, to not crash the browser, I really compressed this file, but you can still see like semi-major axis and planet mass. And whoops. Let me see here. So this is where I got my data. So for well-known exoplanets like 51 Pegasi B, that is the best. Yes, very good. That is the best planet. And I think we have a poster of it downstairs. So I thought, let's take the superstars of the exoplanet world, take that data and plug them into the 3D sphere and see what happens next. And so this is what you're seeing. So this is a screen grab, which I've manipulated a little bit to make it nicer colors in Photoshop. But this is the screen grab in Rhino of these like crazy exploded glitch spheres when I inputted the exoplanet data. So you can still see that there is a bit of a sphere shape to it because I didn't interfere with every line of the code. I would be very consistent, say, okay, I'm going to put like the mass of the planet, like maybe in the first 5 lines, and then I'm going to leave 15 lines as is, and then I'm going to interfere with the next 5 lines, and be consistent so that I would get consistent shapes. And so I really loved what came out there, and it was like surprising in every way. But what was even though these are super lovely, the issue so I ran into 2 issues. So this is always when you're experimenting with stuff and you're doing things for the first time. So my expectation was that there would be a large difference that would be visible between the different planets, and there is a difference. So you can see in this image that the little hat, like that little beak that comes out of the top, is very different. Like it's different from planet to planet, and those 3 spikes that are coming out as well. This was one of my first tests, but they're not super pronounced. So you would need to have a very good eye to be like, say, okay, I'm going to base a new taxonomy really on this. But I thought it would be like, it's still an interesting enough experiment to see it through. And also, I wanted to 3D print them so you could actually have an exoplanet in your hand. And when you are glitching 3D files in a 3D modeling software the way I did, the shapes that are coming out are impossible because they're not closed. So I actually had to go into 3D modeling software and sort of, make them 3D printable. But that is what I did. You see here a couple of more examples. So you'll see some of these. They now live as prints, so I just basically turned them into 2D shapes. And last December in San Francisco, I actually imported them into a VR world. And I kind of had hoped to be able to do that in Hubs, but it would have, I think, crashed our room because they're too complex. But I'm not giving up. Anyway, so these are the 3D printed models that I created based on those glitched spheres, and I color coded them so hot Jupiters would be red, and water worlds would be white, and ice planets, water worlds would be blue, ice planets would be white, so you could tell them apart a little bit. And I placed them in these glass domes, and that is a reference from to Victorian age. So if you think of the science in the Victorian age, it was very much concerned itself with taxonomies and ordering nature into like tidy categories. So, basically one good way to understand something that is new is you just want to give it some order. And so I created this basically sort of box of armoire. I put them all in an armoire and made them into like a Wunderkammer, a cabinet of curiosities. And so, there's this tension between the 3D printed shapes. This is very much an exoplanet search. It's very much the science of today, but it's this contrast with this old way of thinking about science that just concerns itself with creating hierarchies and taxonomies. But we're still a little bit in that space. We still need to create order. But today, science sees the world more like a network, and it's more like a rhizome. But I'm also a sucker for like the idea for the Wunderkammer. So I love this idea. And frankly, at home, I have a little cabinet with meteorites and minerals and like seashells and stuff that I pick up on vacation. So I just love the idea of the Wunderkammer anyway. And it was exhibited at the Université de Montréal, so twice. So this one just shows the Mill campus. That was last year, but before, in the year before, it was also exhibited at Université de Montréal in their Centre d'Exposition, which is a beautiful exhibition space, super large. And I should mention also that I wasn't the only artist in residence at the Montmégantic. It actually went to two artists. There was myself and Jan Poucot, who also does gorgeous work. His work focuses more on light and the nature of light. So the big moon shape there that you're seeing projected at the back, that's a projection of photographs that Jan Poucot took through the telescope at the Montmégantic Observatory. And that he had this like gorgeous slideshow. So it was a really lovely exhibition. And more recently also, at the end of last year, this exhibition was also at the Cosmodome in Laval. So that was a fun place to exhibit as well. So that's it. That's my talk. Thank you again for your patience, with my technical glitch, but I hope you had a good time. And I'm just going to, if you have any questions, about this, just let me know. I'm just going to see if I can turn around. Thank you. This is a fun painting from a different series of moon craters. So you know that I've done maybe a series of moon craters that are named after women. And the drawings are, the size of a regular paper, like I think they're 14 by 17. But I wanted to also to do something really large. And I painted the crater in pink, kind of as poking fun a little bit of this idea of something that is named after women, and therefore it must be pink. I have a complicated relationship with pink, so it's more of an ironic use of it. So how do I think my art could contribute to exoplanet exploration? That's a great question. And actually what was so fun at the exhibition after the residency, we had most of the researchers from Montmégantic and Université de Montréal come to the exhibition. And it was really lovely to see their reaction to the artworks. I think so often when you're a researcher, like in any research, you get very absorbed in your material, and artists provide an outside view. They ask different kind of questions that are maybe not part of the kind of questions that scientists would ask themselves. I find that is also true for the SETI Institute, where we have an artist in residence program. And one of the reasons that the program was started is that the scientists were really interested in the questions that the artists were asking, and helped them to see their own research in a different way. For example, this question, why are we using, solar system-based taxonomies for planets? Is there another way that could be driven by the data of the planet itself? It's a pretty good question. So yeah, thank you, Marie-Eve. It is my hope that I sort of enrich the experience and inspire those who inspire me. I'm certainly very inspired by the art that happens in observatories and in research facilities. And it's because especially astronomy and things like exoplanet research, they're so cutting edge. I mean, this is really where I feel science is at. It's a very fascinating place to get your inspiration and information, and also the kind of that kind of research, exoplanet research, and the search for life in the universe. We're also asking philosophical questions. And I think this is also where art and science really overlap, because the scientists who ask, what may life look like on other planets, or even what may other planets look like? You really, this really borders on philosophy. You really question the human condition and how we think and how we conceive of the world and what time is, what space is. If we're thinking like, in the 90s, early 90s, we didn't think that other planets even existed. We had no evidence that any other planet existed. And now we've got, over 4,000 planets confirmed. And then what's being found is like, and you've seen the NASA posters downstairs, right? So some planets are made of diamond. Some planets, don't even have stars. What is that about? So we need to even sort of rethink how we think about the term planet, if it's no longer means an object that is orbiting a star. So I think exoplanet research is really sort of paradigm shifting, and you need to question your presumptions all the time. I think art can really help there, because anyone who's taken art classes or done an MFA, like, the first thing that you learn is to question everything and think about things differently. And I think that's a good exercise. So yeah, that's how I think, and why I love working at the art science intersection, because it is so rich. But do you have any other questions or comments, either about this work or about anything that you've seen here in this hub space? And thank you, by the way, for everyone for coming. It's great to see you all together. This is so cool. Yeah, thank you, Lancia. Will I continue work on exoplanets? I think so, especially now that I'm more closely associated also with the SETI Institute, where exoplanet research is really at the forefront, because that really interests me. But I'm thinking also a little bit on the terms of astrobiology, so not just exoplanets, like any exoplanets, but how could exoplanets host life, and what would that look like? What would that life look like? Because what exoplanet research has done is sort of expanded our understanding of what a habitable zone is, and the research into extremophiles. And for those of you who were with me on Tuesday for the extremophile drawing workshop. So extremophiles are these organisms that love extreme environments, like they will live in, hydrothermic vent near a volcano, or, be practically boiled alive, or they can be desiccated, they can be, in a vacuum of space, and they're just fine. So that also pushes our understanding of what life could be. And this is a question that gives me goosebumps. So I think this is the kind of thing that I'll be working on for the rest of my life. Thank you, Maria. So also for those who are here, I would like to thank Fourth Space for inviting me to do this virtual residency. It's been really fun, not just to take over the social media, and I think I've been bombarding you with like big questions, like what is life, and with art challenges, but also taking a risk with doing something in Mozilla Hubs. Like none of us had done this before, and I think this is part of research as well, that we're, especially in this COVID world, that we're experimenting with different ways to reach our audience. And I think this has been a lot of fun to see you all here. I certainly don't get Zoom fatigue in Hubs. So I won't have to go down for a nap after this, so that's great. And I hope you have fun as well with the more interactive components. I hope you had the chance to draw on the planet downstairs or make more diamonds at the Diamond Planet, or have chats throughout. Do I think that extremophiles could be found in exoplanets? Absolutely, totally. I think so. The interesting thing about extremophiles is that they're extreme from our perspective. What astrobiology does is that it questions also who we are. So for most of our planet's life, we look like an alien planet. There wasn't any atmosphere, like no oxygen in the atmosphere at the beginning. There was no water, and yet life established itself very quickly. So I think a lot of the extremophiles, if they look at us, they would think we're weird. Us, the Johnny-come-latelys who breathe oxygen, which is, poisonous to some extremophiles. And some extremophiles like endoliths, those are organisms that live inside rock and sort of metabolize rock. Studies have shown that there may be more endoliths in weight than all the other life that exists on this planet. So, maybe they're in the majority and we're the weird ones. And if you extend that to other planets, as soon as we go to another planet, we're the alien. So I definitely think there would be life elsewhere. And I hope that it's very strange. Kendra asked about tweaking the code and that it must have been fun. That was super fun. So when I first had the idea of glitching the code and then printing it, I actually worked with the Digital Fabrication Lab at Concordia University and just brought the idea to them. And it was fun because the consultant who was working with me at the time, he says, normally people come to me and they ask me how I can make my model print better. And you coming in here and you're asking me, how can I break my model? And it's like typical artist. And they'll go like, yeah, pretty much. And it was really fun to figure out how to get to the code and how we had to save our Sdl file so I could tinker with it. And but then once it worked and I was able to sort of re-import it into Rhino to make the three-dimensional shape, this is super cool. And I was just so delighted. And breaking things also, it's basically a transformation and it opens up new possibilities. So I think it's fun. It was a fun approach, and I'm continuing to work with 3D printing, and I have my own 3D printer now, so the tinkering continues. So if you, oops. Yeah, so I'm going to leave the PDF up if you guys want to interact with it and just, click on it. And you can also reach me on my website and through my email. Or just follow the hashtag #4thSpaceAliens. I'll be in virtual residence for the rest of the week, well, which means today and tomorrow. But even after that, just use the hashtag and you'll get to me. So thank you very much for being here.
Thank you, Bettina.
Thank you. All right, so I'm just gonna head back down and feel free to chat. The event goes till 1:30, but don't feel like you have to leave on time. I'm just gonna leave the room open.